Hello and welcome back to the ILTV Podcast. I'm Maayan Hoffman, Executive Editor of ILTV, and we're so happy to have with us our viewers and listeners. We're also very happy to have a special guest today, Gil Hakim, the CEO of Matricelf. He's going to tell us more about what that is. Welcome, Gil.
Welcome. Thank you.
Of course, now, Gil, last month, every major media outlet had the headline about the world's first spinal cord implant that is hopefully about to take place in the near future in the state of Israel. For those who don't know what that means, I'm wondering if you can just start out by explaining what exactly, in simple terms, is supposed to be happening soon in the state of Israel. What does this mean?
Yeah. Well, the basic of our technology is to create tissue out of the patient's own cells, and we chose the spinal cord. Spinal cord is a tissue which is connecting between the brain and the muscles. And in cases where there is a severe injury, traumatic injury, like car accidents or others, there is a cut in this connection. So what we have developed is we take the patient's own cells and we are creating a minor or micro spinal cord. A micro spinal cord, when you look at it through the microscope, it functions like a normal spinal cord. And we take that spinal cord and we place that inside the area where there is a cut in the connection. There is an injury, there is a gap there, and it is placed, connects naturally with the existing or the host severe traumatic or the injured spinal cord, and these connections regain for the body or for the patient all movement and all function. So that's what we are planning to have the first patient ever to have the ability to have a real treatment for spinal cord injury, and that's something which we are really looking forward for that.
It sounds like, a fairy tale too good to be true. Now, why here in Israel? Why do it in this country? And why is this considered a huge milestone for Israeli science and medicine?
It is. Well, it's the first ever treatment, a cure for spinal cord injury, for paralysis.
Assuming it will work, right?
That's the idea. That's the option that we are giving here. All the rest that were done until now is a supportive medicine, is stimulation, electrostimulation for external one. We are the first one to develop something which is a real cure. It shows really good evidence, overwhelming evidence in the rats model, and now we are moving to the first in human, and we're doing this in Israel because it was developed in Tel Aviv University by Professor Tal Dvir. It is through long research that he has done for more than 10 years in his lab, and I think it's natural that we're going to be proud on the fact that our first patient to possibly enjoy this treatment should be in Israel.
Incredible. I think back more than 10 years ago with the rewalk, and how, I always remember being at an APAC convention and somebody came out, wearing it and walked across the stage for the first time, or Ilu as if walked across the stage, because rewalk, of course, was not a treatment, but rather a device. And here this would be, I'm just picturing a real, person just being able to walk with nothing,
exactly,
not
without
assisted.
No external assistant, and it's a real treatment, and it's not just walking, it's feeling. Because the spinal cord transfer not just the actions to move, but also to feel.
To feel
everything
that,
that we feel,
right.
It goes back to the brain. Right. And everything to act goes from the brain back to the muscles. So what we are providing, that's the uniqueness here, is it provide a real, I would say, connection that is biological to create this transfer of information back to brain and from brain to the body.
It's interesting because there are millions of people around the world who actually have spinal cord injuries and are potentially not able to walk or have other challenges, not only in Israel. Here, of course, unfortunately, because of some of the wars, there are many more soldiers and others who are injured. But this seems like something that we should have had a cure for so long ago. Why do you think it is that it has taken so long to get to this solution?
The spinal cord In the spinal cord injury, there is a situation where it's unique to other injuries. What happened is the spinal cord is a very delicate area. It transfers information from the brain to the muscles. After the injury, what happened is that the body, as a matter of to protect, this is a normal protection mechanism, form a scar. Like when we get a cut, it forms a scar. In a normal place, in a normal situation, a scar is okay. It doesn't have any impact. In the spinal cord, the scar is like a wall. Imagine that you have information through wires that going through this from one place to another, and you have a cut. A cut is one thing, but what happened is that the scar formed like a wall, a
like
barrier.
A barrier, yeah.
So anything that you want to treat won't work because this barrier will prevent from the information to cross. So in our surgery, in our treatment, that's what is unique, is that the surgeon remove the barrier, expose the wires. Think about that, exposing the wires, and then place our product, I will call it the tissue, and this tissue sends like fibers, connects with the fiber of the patient, and resume communication.
Wow, I mean,
so that's unique. Nobody has done this before. That's the advantage. Now, another thing which we have to take into account is that the spinal cord or nerve system is very delicate. If you place a donor from a donor, in case something happened, and you can take a donor and make nerve cells.
Like replace the cells or a new spinal cord or something from someone else.
The donor, the reaction, I would call it the rejection process, can inhibit any kind of formation of these new wires because this is very delicate. If you have any process of rejection, of inflammation, which is the process of rejection, it will inhibit any kind of connection. So we overcome that by the fact that we are taking the patient's own cells. It's fat tissue and blood cells. We take that, convert that through genetic engineering and tissue engineering technologies that we have invented, and you get back nerve cells which are identical to the cells of the patient. So there will be no rejection. So you overcome the risk of rejection, the risk of the inflammation and all that. So these are the things that why we think we can solve this problem.
And as you said, it worked in rats, but there's a big jump usually from rats to people. So what gives you the inclination at this point that you think this is going to be successful when you try it in humans?
Well, smarter people have decided that. The FDA have decided and checked what is the best model that gives you the best prediction to humans, and it was a rat model. The rat model, the severity of the injury, the process of after the injury is similar to humans.
Wow.
So what so the model that we have chosen is exactly the model that the FDA have given us, and this model this is what we chose. We have. Yes, we paralyzed the rats. Yeah, so their hind legs are not moving anymore. We placed the implant that we have developed, and after a few weeks, the rats began walking. So that gives us I would call it the confidence to show that this will work. 80% of the rats start running. So what
cool.
after paralysis, yeah.
Wow.
So with this information, we applied for the Israeli Minister of Health to ask for permission to perform compassionate program.
Right.
And they gave us a principal agreement that will allow us to treat that only if we pass several technical barriers, I will say, we will allow to treat the first patient. So this is what we're doing right now, doing all these technical process. There is a technical process that we have to finish. And once that is completed, we can have the first patient.
How are you going to go about choosing who is the lucky person to get to have this first?
Okay. It's the doctors to decide. We start with those who have recent injury.
Okay.
Within a year of the injury. Why is that? Because the body is still, I would say the muscles are still working, and it's not long it's not long ago that they got the injury. So when we place the implant, the regeneration power, the rehabilitation after the implant will have greater success or greater chances to succeed. So that the first patient will be probably young, with an injury that is just a year and a half, and we start with thoracic. That means we start with paraplegic. That means legs are waist down are with a complete injury, paralysis, and we will move to cervical, like the case of Christopher Reeve. So this will be the next step. So we start with those with waist down, paralysis with waist down, and then we move to do those with the neck down. I would call it paraplegic, tetraplegic. And we start with the fresh wounds, I would call it, and we will move further as we develop, as we see that it works. Okay, we will expand and we work. So in the future, yes, we will treat those that are on wheelchairs for 10 and 20 years. That's the goal. But we start with those that, we need to build confidence, and we need to show that this thing works. Yeah. So you need to provide the best surrounding for that. For instance, I will not, if something happened, I will not be the first because I'm too old.
Well, what is that age that we need? So let me ask you, in terms of follow-up, what success will look like if you go make all the criteria and you move forward, you select a patient, the patient has the treatment. Will it be a few steps and you'll say successful? Will it be them running across the floor?
Okay.
How long will it take?
So the success criteria are very, very different. There's different success. What we think is success, what the doctor thinks is success, and what the patient thinks is success. For instance, a survey that was done on over thousands of patients, paralyzed patients, neck down or waist down, they're asking, what is the top 3 things that you would like to recover? I thought will be walking. Everybody, as I ask, will be walking will be number 1. It's no. Bodily function.
Oh, wow. Makes sense.
Yeah, they want to be independent again. They want to restore function. So bowel and bladder function, this is something which they see, they looked at is the top thing. Yeah. So for the doctors, the fact that they regain movement. For the patients, it's that they regain the fact that they're independent. We think they want to walk again. So we will measure everything, and we will know. We will see.
Fabulous. Now, I imagine that it's going to be very emotional when you meet patients or families that have somebody struggling with being paralyzed. What do they ask you? Like, what are their first questions about, in case they would qualify or when they could get access?
It's really tough because, as I explained, we are very picky. Not just us, the doctors as well. We are very picky on the first patients, but they give us the hope or the power that there is I would say the ultimate goal is to treat all paralyzed people. Yeah, so I ask them to be patient. Yeah, and to follow what the media, how we progress. And eventually, hopefully, they will be included in the next step. But we have to finish the first step with those who are have the higher chances to succeed.
Sure, because I'm guessing also once you've been able to show success, then the Ministry of Health won't require it only for compassionate use, but eventually it'll just be approved, and then you would have more ability.
Exactly. They will have Exactly. You have to show results in order to get back more confident from the FDA or from the Ministry of Health. It doesn't matter. Yeah, correct.
Now, you mentioned before that this was actually started in a lab at Tel Aviv University, in Tal Dvir's lab. This is his brainchild. And then it became this company, Matricelf, which, if I remember correctly, matrix, self, and cell. Okay. So tell me a little bit about how it goes from the lab to a company.
So Professor Dvir was done this research for the last 15 years, and once he's done a lot of things in his lab. He printed the heart. He printed the living heart. Small, but still in 2019.
I remember writing about that. He used to be a health reporter. Him. That's crazy. I didn't realize it was him. Okay.
And he did amazing stuff in his labs. And by that time, he did a mouse study on spinal cord injury.
Okay.
Once there was it's real product, it's real something that has potential to work. Together with Alon Sinai, they form Matricelf, established Matricelf, and Matricelf got license from Tel Aviv University to commercialize the technology that was developed. So we have a license, exclusive license from the university to develop that. And our first product to develop out of the platform is spinal cord injury. But it's just the tip of the iceberg because it's a platform. We can do a lot of things. We start with spinal cord injury, but we will move to traumatic brain injury, to stroke, to various indications, which the common, I will say the common thing for all those indications that you have a damaged tissue that needs to be replaced. Mm-hmm. So it can go to liver. It can go to everywhere.
Incredible. And, it's a really fitting time for things like this to be coming out. I think 2 years into a war where we talk a lot about the number of soldiers that unfortunately have died in the war, but there have been so many that have been injured and so many who are injured. We also talk about the 1,200 on October 7th, but there were thousands who were injured in different ways that day that are struggling still to recover and go through rehabilitation. This might be still a pipe dream at this stage. We haven't even done the first treatments, but it seems to me that, if I'm hearing correctly, a lot of those kinds of injuries where we talk about, paralyzation, traumatic brain injuries, these kind of things would be potentially then treatable if this treatment comes to fruition.
Exactly. It gives us, it's fortunate that we have the ability to help those, and because there is no treatment for this kind of injuries. And we will include those. Obviously, this is the top priority, to include those who injured and it's actually, they fit. They are young.
Unfortunately.
Yeah. And it's fresh in a way. Yeah. So that's that. There will be in the line on the first year after we start with those who are really, really fresh, not just 2 years. I'm talking about less than a year.
Yeah.
So if we are planning to treat those patients, it probably will be toward 27, 28.
And when you started to think about turning this science into something that could actually serve patients, how did you decide on this particular treatment versus all the other ones you just named?
Spinal cord injury is very, in a way, simple. 0 or 1. 0, no movement, no feeling. 1, everything goes. So it's like engineering. It's an engineering type of work. Comparing to traumatic brain injury, which it has a very I would say, different aspect of the injury. They cannot talk. They cannot. There are some cognitive problems. The injury is not just simple as I cannot move. Mm-hmm. So we started with the spinal cord injury because it's very easy. Everything works. Their muscle works. Their brain works. Everything works. It's just a tiny, I will call it, missing piece that was cut, was injured, and we just, yeah.
Sounds so easy.
Yeah. We placed this link, this bridge. So we chose that in terms of where we will show success easier and faster.
Biotech, though, is such a difficult industry. I mean, first of all, it's a very expensive industry. The science is super hard. I mean, Israel has been in some ways at the forefront, but in other ways not. It's been a difficult field here in Israel. And now you also have the expectations of the patients that this is going to work. So how do you balance the business, the science, and the expectations?
Well, it's very challenging, especially the last 2 years for biotech companies. So our work is to try to present and talk and publish everything that can be done or what we are doing in order to attract the attention. We talk to VCs, we talk to potential investors. By the way, we are traded in the Tel Aviv Stock Exchange.
Oh, okay.
So that's also a platform that people can see what we are doing. Every small step that we are achieving, we have to publish. So that's another platform that people see. So taking all this thing all together, we raise the funds. We are actually now raising funds all the time. We have to all the time to raise funds in order to support the development of that of this product. For instance, to create one implant, it takes 6 months. So we take the patient blood and take the patient fat tissue, and in the lab, in a special lab, in clean room, special lab, it is grown to functional tissue over 6 months. So this is costly. So this thing is we have to cover that. So that's why we are going to we need funds to continue develop the product, but eventually. The value is, for instance, in the U.S., those patients which are injured, which are paralyzed, are costing the insurance companies up to $6 million per patient.
A year or lifetime?
No, lifetime. The first year, around $1.5 million. So they will really like, if everything goes well, if the clinical program will be successful, there is a very high need to find something to replace this $6 million expenses.
Yeah, for sure. Now, if this works, could the same technology be used not only for some things you named, but also for maybe trauma, people that have like disease or damage to the nervous systems, like maybe ALS or things like that?
Unfortunately, at this stage, we are looking at only local trauma.
Okay.
ALS is not local,
right,
it's more diffused. Like, for instance, Alzheimer. It's more diffused.
Right.
But stroke, yes.
Oh, wow.
Because stroke is just an area which has been damaged.
Right.
So we can locate that area. Because you see the area is dead. The
right,
area
that's
is
totally
dead.
wild.
So you locate the area, you take the patient blood and fat tissue, convert them to nerve cells, brain, to a tiny brain. Actually, Professor Tal Dvir, was able to build tiny brains in his lab and plant them in cases of traumatic brain injury.
That's incredible.
So that's the future. So looking at where you can localize the trauma and replace the damaged part. So in ALS or in Alzheimer or everything which is diffused disease, it's less relevant now. Maybe in the future, I don't know.
But not with today's technology. Yeah. Do you see Israel becoming a global hub for treatments like this, where people from all over the world will eventually come to Israel and want to get this spinal procedure?
The beauty about that is that Israel could be the hub of producing those implants. A person in Chicago, injured one, we only need to take a blood and his piece of his fat, deliver it to Israel. We'll grow the tissue, and then this tissue, it looks like, by the way, the tissue looks like hundreds of the size of this tissue implant is like a caviar. Looks like that, small, slightly. Yeah. So you have 100 beads, spheres, hundreds of spheres. So it's in a test tube. You put everything in a test tube. So this test tube is delivered back to Chicago, whatever, and the neurosurgeon there will treat So we will be the hub for treating all those people around the world. They don't need to fly to Israel, but we will be the major part to manufacture this.
So the last question that I have for you is just for you to really think about how this makes you feel. It's a world first. Nobody else has it. No one else has done it. God willing, we're going to be doing it here soon. And when you think about it just personally, that you are part of this team that is, God willing, created something that could really change people's lives, how do you feel about that?
I joined a year ago. And in my past, I think 25 years, I've been leading companies, biotech companies, the medical device, in pharmaceutical one. And it was a very satisfying journey. When I was introduced to Matricelf, I said, I have to be there. This is something which is really big than anything else that has been created here. That's why my personal thinking. And I said, I want to join this team because once we will show the first patient, come on, it's like it's the impact. It's revolutionary. It's everything that you want to be part of in medicine. So I personally was very happy that I joined, and hopefully next year we'll talk again, maybe with a patient.
100%.
We'll see.
Yes. So is there anything else you want to add or anything else you want to say that I didn't ask you?
No, everything is, we're just looking forward for the next steps. I thank you for this opportunity to present, and I will be very happy, people that if you want to call to check what's going on with Matricelf, just visit our website. That's what I thank you for that.
100%. Well, thank you, Gil Hakim, the CEO of Matricelf. Thank you so much for being here today.
Thank you very much.